Welcome to this modern JavaScript refresher. JavaScript has evolved rapidly in recent years, introducing new syntax and functions to make our code cleaner, more powerful, and more efficient. Today, we'll explore some essential features, from simplified syntax with arrow functions to more advanced techniques like promises and async await. So let's dive into the modern JavaScript features. Let's start with arrow functions, one of the most well-known modern features. Arrow functions simplify the syntax for defining functions. Here, we create a simple function to add two numbers, showcasing the difference between the traditional function keyword and using an arrow function. Using an arrow function, we can define add function as a single line without needing the function keyword or even the return statement. Arrow functions offer concise syntax, especially for one-liners. On the other hand, using the traditional function syntax requires us to explicitly use return to produce the output. This comparison shows how arrow functions can streamline code, making it both shorter and often easier to read. Arrow functions in JavaScript offer several syntax shortcuts that help make code more concise and readable. Let's go through a few of these handy shortcuts. First, when using a single parameter in an arrow function, you can skip the parentheses around it. However, with multiple parameters, you do need the parentheses to enclose them. When there are no parameters, you still need to include empty parentheses. Another convenient shortcut with arrow functions is omitting the curly braces and return keyword when your function contains only a single return statement. But if your function includes more than one statement or performs additional operations, curly braces are necessary to define the function body. In these cases, if you wish to return a value, you'll need to explicitly use the return keyword. Lastly, if you are directly returning an object, wrap the object in parentheses to prevent JavaScript from misinterpreting the curly braces as a function body. If additional logic or operations are needed, use braces and an explicit return statement to return the object. These shortcuts make arrow functions especially useful for callbacks and other quick, single-purpose functions. They simplify function structure without sacrificing readability, keeping your code clean and concise. Arrow functions introduced a major change in how we handle the this keyword. Unlike traditional functions, arrow functions don't bind their own this. Instead, they inherit this from the surrounding lexical scope. This is particularly useful when working with methods inside objects or within callback functions, where this might otherwise point to an unexpected object. Let's take a look at an example to see this in action and how it can help simplify our code. In this example, we have a game object with a title and list of players. We define two methods, one with a traditional function callback and one with an arrow function. When we run listPlayer's the traditional callback function within for each does not recognize this as the game object. Instead, it points to the global context, causing this.title to be undefined. But with listPlayerSuro, the arrow function callback inherits this from its surrounding scope, correctly referencing game. This makes arrow functions a great way to simplify callbacks by keeping the expected this context intact. Next up, we have template literals. Template literals make string handling much easier, allowing us to embed variables and create multi-line strings without awkward concatenation. In this example, we are using a template literal, which allows us to embed the named variable directly within the string. By using backticks instead of quotes, we can easily insert variables or expressions into the message, making our code cleaner and more readable. Here, the named variable within dollar and curly braces is replaced with the value John, and the output becomes, "Hello, John. Welcome to Modern JavaScript." Destructuring allows us to extract values from objects and arrays efficiently. This makes code more readable and reduces redundancy. Destructuring shines when dealing with complex data structures. Here, we are pulling the name and age properties directly from person object using object destructuring. This syntax makes our code concise and eliminates the need for repetitive references like person.name. Just like with objects, array destructuring allows us to unpack values into individual variables. Here we have an array called fruits with three elements: apple, banana, and cherry. By using array destructuring, we assign each fruit to a separate variable in a single line of code. The first element in the array is assigned to first fruit, the second to second fruit, and so on. This makes it easy to work with each item in an array individually without needing to access them by their index. The output shows each fruit logged individually: apple, banana, and cherry. Destructuring is a clean and efficient way to handle data in arrays. The spread and rest operators, both represented by three dots syntax, let us expand or gather elements from arrays and objects. It is one of the most versatile tools in modern JavaScript. In this example, we use the spread syntax to seamlessly combine arrays. The colors array contains three colors: red, green, and blue. By using the spread operator, we create a new array called newColors with yellow at the beginning, followed by each color from the colors array. The spread syntax expands each element in colors into the new array. So the output shows yellow, red, green, and blue, confirming that all elements have been merged smoothly. This demonstrates how the spread operator can easily merge or extend arrays. In the addNumbers function, we use the rest operator to gather multiple numbers into an array to sum up, making the function flexible with any number of inputs. When the function is called with arguments 1, 2, 3, the rest operator gathers these arguments into an array of elements 1, 2, and 3. Inside the function, we loop through each number in the array and add it to sum, which results in 6 when printed. We can also call addNumbers with a different set of arguments, such as 1, 2, 3, 4, and 5, and the rest operator will gather all 5 values into an array, giving us a sum of 15. This flexibility makes the rest operator particularly useful when dealing with an unknown number of function arguments. Default parameters. With default parameters, we can set default values in function arguments, preventing errors when certain arguments are omitted. Here, parameter name defaults to guest if no argument is provided. We call greet once without arguments, which defaults to guest, and once with Alice. This way, our function can handle missing arguments gracefully. Let's explore 3 powerful array methods: map, filter, and reduce, each offering unique ways to process and transform data. Map transforms each item, filter removes unwanted items, and reduce accumulates a single value. Let's start with map. The map function is used to create a new array by transforming each element in an original array. It applies a given function to each item, leaving the original array unchanged. For example, here, the map function goes through each number in the numbers array, doubling each one. The original array remains the same, while the new array called doubled holds the transformed values. This is especially useful when you need to apply a transformation to each element in a collection, like adjusting all prices by a set percentage or converting measurements in a dataset. The filter function is used to create a new array that only includes elements that pass a certain condition. Each item in the array is evaluated with a callback function that returns either true or false. Only items that meet the criteria, return true, are added to the new array. In this example, we have an ages array with various ages. Using filter, we define a condition for adulthood, so only those that meet this condition are added to the adults array. The filter method is perfect for removing unwanted items from an array, while keeping only the ones you are interested in. Now let's explore reduce, which is the most powerful of these methods. Reduce allows us to take an array and reduce it down to a single accumulated result, like a sum, product, or even a complex object. Reduce takes two parameters, a callback function and an initial value. The callback function itself takes two arguments, the accumulator, which holds the result of each iteration, and the current element being processed. Let's look at an example where we calculate the sum of an array of numbers. Here, we start with an initial value of 0 for the accumulator. On each iteration, reduce takes the current value of the numbers array, adds it to the accumulator, and then returns this new total to be used in the next loop. By the time reduce finishes iterating, accumulator contains the total sum of 10. Now let's consider a more complex example, creating an object that counts occurrences of items in an array. In this example, we begin with an empty object. For each fruit, we update the count in the object by either adding one if the fruit already exists, or setting it to 1 if it doesn't. In the end, count contains the tally of each fruit. So, reduce is powerful for transforming arrays into single values or even complex structures like objects, especially when you need more control over how data is aggregated. Optional chaining and nullish coalescing allow us to safely access deeply nested properties and set fallback values. With optional chaining, we avoid errors by safely accessing nested properties. Nullish coalescing allows us to set fallbacks only for null or undefined. Async await syntax streamlines handling asynchronous tasks, making code easier to read and understand. Using await, we pause code execution until the fetch completes, then proceed with data, a cleaner alternative to callback-based async code. Enhanced object literals bring a more efficient way to create objects, making JavaScript code simpler and cleaner. Before enhanced object literals, creating an object that had properties or methods using external variables required extra steps. With this feature, JavaScript lets us define object properties and methods with less code, especially when we use the same variable names or need methods directly inside an object. This feature includes three main aspects. First, shorthand property names. If the property name is the same as the variable name, we only need to specify it once. Then, shorthand method definitions. We can define methods inside an object without the function keyword. And computed property names allows dynamic key names, letting us calculate property names based on an expression or variable. Shorthand property names. In this example, we have variables name, age, and job, which are assigned values outside the object. Without enhanced object literals, we would need to assign name to name property, age to age property, and so on. But with shorthand, simply writing name, age, and job assigns these values directly from the variables with matching names. Shorthand method definitions. Instead of defining greet function using function keyword, we use greet directly. This shorthand makes it clear that greet is a method of person object. Computed property names. The expression concatenating is and active is used to dynamically generate the property name is active. This flexibility allows for more powerful dynamic object construction, especially when property names are not static. In summary, enhanced object literals reduce the need for repetitive code, allowing for simpler and more readable object definitions by utilizing shorthand syntax, direct method definitions, and dynamic keys. This feature is especially useful in scenarios where objects rely on external variables, or when object properties need to be calculated. JavaScript modules are a way to organize code into smaller, reusable sections. By breaking code into individual files, each with a specific function, modules make large codebases more manageable and less error-prone. In JavaScript, we use export keyword to expose specific parts of a module and import keyword to bring those parts into other files where they're needed. modules support two main types of exports. Named exports allows exporting multiple items, such as functions or variables, by name. Default export allows exporting a single value or entity from a module, making it the primary item to import. This approach to code structure improves reusability as different modules can focus on different functionalities. In this example, we have a file called mathutils.js with an add function that adds two numbers together and an multiply function that multiplies two numbers. We export these functions so other files can use them. Now in our main file, app.js, we import the add and multiply functions from mathutils.js by specifying their names in curly braces. This lets us use them as if they were defined directly in app.js file. Modules are powerful because they keep code organized, reusable, and help prevent naming conflicts by isolating functionality. As we wrap up this refresher on modern JavaScript, we've covered essential tools and techniques that make JavaScript both powerful and dynamic. We started with the streamlined syntax of arrow functions, then moved through destructuring, spread and rest operators, and practical array methods like map, filter, and reduce. We also explored template literals, optional chaining, modules, and async features to manage asynchronous code with ease. Each of these tools simplifies development and enhances readability, making JavaScript a truly dynamic language for today's coding needs. Thank you for watching and joining us on this journey through modern JavaScript. If you found this refresher helpful, please give it a like and consider subscribing for more programming insights. Don't forget to hit the bell icon to stay updated with our latest content. Keep exploring JavaScript, and we'll see you in the next video. Keep coding, and we'll see you in the next video.